how to evaluate sine theta, cosine theta, and tangent of theta. Here, theta just represents an angle, right? So sine of like pi over 3, or cosine of pi over 3, or tangent of pi over 4. That's what we're going to be up to today in this specific video. Take down the title, of course, make sure you've got it labeled appropriately, and we'll move on soon. Great, now that you have that done, Joe, look, I don't know how to do this right away either, right? If I do cosine of pi over 3, you don't know what that is, you plug it in the calculator, it gives you decimal, like kind of wrong, right? So let's figure out how to use the unit circle to tell us what's happening. Let's flip the page. Make sure you take these down because we're going to come back to these. So either sketch quadrant 1 quickly or get out a blank copy of the unit circle. Look, I'm going to start with this example here. This is a triangle that I have. Here's theta. I know that theta here is 30 degrees or pi over 6. Now you should know SOHCAHTOA. It's helpful, I suppose. And that means that sine of theta, because you can't just write sine by itself, that's sin, which is not allowed. It's very bad. So sine of theta is the opposite over the hypotenuse. Now we already know what this triangle is. We know that it has a height of a half and it has a width of square root of 3 over 2. And we know the radius is 1, or the hypotenuse is 1. So we're going to use this triangle that we know to evaluate sine, and I'll write it here, I suppose, sine of pi over 6. So sine of pi over 6 would be opposite over hypotenuse. What's the opposite of pi over 6? Well, that would be the side that's opposite that angle, so 1/2, divided by the hypotenuse, which is 1. And look, anything divided by 1, anything at all, it's always just the thing on top. So that means sine of pi over 6 is 1/2. Good. Let's find out what the cosine of pi over 6 is. So cosine of pi over 6 is equal to the adjacent over the hypotenuse. We're going to use the same triangle because it's still pi over 6, and the adjacent side is this one, so one next to the angle, so square root of 3 over 2 divided by the hypotenuse, which is 1. What is that? That's right, it's just square root of 3 over 2. Now, if you remember, the coordinate point right here is square root of 3 over 2 comma 1/2. So that's interesting, but I won't get into that quite yet. Let's look now at this next triangle, this blue one here. That's right, the angle here is pi over 3, or 60 degrees. So let's find out, again, sine of pi over 3. The sine of pi over 3 is this opposite side here. It's the opposite side over the hypotenuse. The hypotenuse is still 1 because it's still the radius. So what is this opposite side here? Well, that's square root of 3 over 2. So square root of 3 over 2 over 1, that's square root of 3 over 2. In other words, look, what we found is so far just one thing, right, that we can evaluate using the triangle. And we're about to make another connection. Look, where does the square root of 3 over 2 go in these blanks? Yeah, it's the y value. Why is it the y value? Because it's the height, right? And what's the x value? It's 1/2. So maybe it's not apparent, or maybe it is, but let me just ask it. Look, sine corresponds to which of these two values? Okay, good. I think you've thought about it. sine corresponds, well, sine was square root of 3 over 2, that's the y value. What about over here? Sine of pi over 6, the smaller triangle was, or the smaller angled triangle, was 1/2, and that was the y value. So let's make a general connection. The sine of theta equals, guess what? The y value. Cosine of theta equals the x value. So when I'm looking at a coordinate point, like this one, and we know this one already is 0, -1, that means that sine of this angle here, 270 or 3 pi over 2, sine of that would be the y value, so -1. And cosine is the x value, so cosine would just be 0. So you can see now it's abundantly clear that we can just use the unit circle to tell us what sine and cosine and tangent are, which is lovely. It's a great tool. So any coordinate, x, y, on the unit circle can be written as cosine theta, comma, sine theta. That's a key point, and that is what's going to help us go back and do these problems here. So let's do cosine of pi over 3 first. Like I'm going to do these, do this one, and I'll do cosine of a -pi over 4. That's it. And then I'll just give you the solutions to check your own work, what you need to do. So cosine of pi over 3, let's see, where's pi over 3? Pi over 3 is here. So pi over 3 would be which value? Yeah, it would be the x value. So if I'm saying cosine of pi over 3, I just need to choose 1/2. So cosine of pi over 3 is 1/2. It's that simple. So I do one more. Cosine of a -pi over 4 is, now here's the thing. Remember what negative means? That's right. So pi over 4 is here, but a -pi over 4 means we're starting right here and we're going back 45 degrees. We're going back pi over 4. So that means I'm talking about that coordinate point right there. And cosine refers to the x or the y. The x, that's right. So I just choose the x value, which is, that's right, square root of 2 over 2. And I'm done. Now, the only thing that I haven't really explicitly told you is that tangent of theta is also the same as sine of theta over cosine of theta, by definition. Which means if sine is the y value and cosine is the x value, then to find tangent, we need to just pick the y value and put it over the x value. Okay, so now do these practice problems and check your work when you're done. Do these problems. Look, only when you've done that should you unpause it and then actually check these. Okay, so go ahead and actually, nope. Okay, nope. Nope. Okay, go ahead and actually check them. You might be asking about this problem. Look, it's the same thing over the same thing, right? So that means it's just 1. Look, and that's it. If you feel confident in that, great. If not, bring some questions to class, or just try making up your own and evaluating them. And then you can ask me about those.